Good morning, my YouTube viewers. It's Crystal here. I want to give you a code review on a Kaggle community competition called Predict the Salary for Data Science Jobs. And this community competition was actually written in another language. I think it was Spanish, but I can't be sure. So I went ahead and entered the competition because the data sets were written in English, although the competition itself was written in another language. I also want to give a shout out to Data Manual because I received a message from Kaggle this morning from Data Manual asking me to look at her work and give her an upvote. So I called up her page on Kaggle, but I don't know what work to look at. I had assumed that she had entered the community competition and I could look at that work, but she didn't enter the community competition. So she's got a couple of gold medals, some silver medals, and some bronze medals. So obviously she does really well, and I suppose I will have to look at her work at some point to see if I can improve my work. Since she's got some gold medals and silver medals, I can see what she did to do it. But unfortunately, so I did look at her work. I'll have to go in and look at her data sets and see what she did to the code to get a gold medal or even a silver medal, because I've got tons of bronze medals. So there's my shout out to Data Manual. And so what we're going to do now is we're going to do this code review on DS Salaries. That's Data Science Salaries. And I use Keras Tensorflow for that because I'm studying Keras Tensorflow. And because I'm studying Keras Tensorflow, I want to do my work in Keras Tensorflow. And the reason why is because sklearn is considered like a toy library. And then if you want to get really deep into data science, machine learning, you need to use Keras Tensorflow or even PyTorch. And I have used PyTorch in the past, but I'm going to see how I get on with Keras Tensorflow. I'm hopefully it'll be easier for me to work with Keras Tensorflow than it was for me to work with PyTorch. So having said all that, we'll go ahead and proceed with the code review. And you can see that I submitted my work to Kaggle and I had 52,392 and I'm number 10 on the leaderboard. So whenever I initially did it, I was like number 8 on the leaderboard, but now I'm number 10 on the leaderboard because that's the name of the game for entering these competitions. Then what you do is you look at the code of other people to see if you can improve your score. But if you look on the Predict the Salary for Data Science Jobs, I'm the only one that made my code public. Other people haven't made their code public, but I make mine public because I want to do a code review and a blog post on it. So that was what I predicted. So I created my program on Kaggle's online free Jupyter notebook. So the first thing that you do is you import the libraries. So we imported NumPy as MP, and that's your numeric computations. We imported Pandas as PD, and that's your data processing. We imported TensorFlow as TF, that's your neural network. We imported OS, which is your operating system. It's an inbuilt library. We imported matplotlib.pyplot as PLT, which is your visualization. And we also imported Seaborn as SNS, which is your visualization. So we read the files. We used OS to go into the operating system and get the files that we're going to be using. The files that we're going to be using are going to be the salaries data is your train, the testio is test, and muestra is your submission. And then we read the files using pandas and created data frames out of those files. So we have train, test, and submission. So here's our train. Here's the train info. So you can see that it is 500 rows for 11 columns, and you've got integers and objects. We check the columns. These are the number of columns that you have if you want to see the columns. We drop salary and salary currency. And the reason why we drop salary and salary currency is because it's not on the test file. And since it's not on the test file, there's no point in having it, although it's nice to see what the currency was and what the salary was. But what they do is they take the salary and they convert it to US dollars. Check to see if we have any null values. We don't have any null values. Now we check the test file. It's 107 rows by 8 columns. And it doesn't have the salary in USD, doesn't have the salary currency, and it doesn't have the salary. We check the test columns, so there you can see what columns we've got. We check to see if we've got any null values, and we don't have any null values, so that's good. We don't have anything to impute. And now we check the submission, and this is the format that Kaggle wants to see when you submit your work. And here it says it's 107 rows by 2 columns. Okay, so yeah, 107 rows by 2 columns. So now what we're going to do is we're going to analyze train. So we make a histogram of salary in USD because that's your target. So you can see that we've got some outliers there. So we check to see if we have any targets that appear only once, and we've got quite a few targets that appear only once. So we filter out all the targets that appear only once because it's not going to do any good in the prediction if you have a target that appears only once, because the computer is not going to be able to compare it to another target. So I just filtered out all of those target values that appeared only once. And so the only thing that you got was if the values that appeared more than once. So now we have 271 rows. So it took out almost half of the rows when we did that. But it's better to do that than to have values that appear only once, because it adds no meaning to the prediction and it's just going to contribute noise. So now we're going to make the target is going to be train salary in USD, and then we're going to do salary in USD again. So this is our new salary in USD, and you can see that it got rid of the values that appeared only once, and you've got one outlier. So I decided to leave the outliers in there. If I had wanted to, I could have inserted code to remove the outliers, but I just decided not to. So now what we want to do is we want to check all of the number of unique values in the train data frame. So you can see the number of unique values in the train data frame. So now what we're going to do is, since we have assigned our target as being train drop salary in USD or train salary in USD, we're going to drop salary in USD. So now we don't have the salary in USD anymore. So now what we want to do is we want to look and see what all the unique values are. The work year is 2020, 2021, and 2022. Gives you your experience level, gives you all of the unique values, so that's good. So I made a box plot in work year, and you can see that in 2021, salaries were higher than 2020 and a little bit higher than in 2022. I did a box plot on experience level, and you can see the salaries were highest in the EX, so I'm assuming that's expert. And I'm not sure what SEMIN means, but EX is definitely higher, and so that's one thing that you know. We also did a box plot on employment type. So people on the full-time got more money, part-time and FL got less money, and CT, I'm not sure exactly what that is. So now we did a bar plot on employee residence. So you can see the employee residence. You can see what their salaries were. So the highest salary, it looks like MY. I'm not sure exactly what MY is, but I think it might be Malaysia, because they've got a lot of engineers in Malaysia. And then you've got India, so India's got quite a few engineers as well. And US, the salaries in the US are not as high as India and Malaysia and PR. I'm not sure exactly what PR is. And now we're going to look at the company location. So the salaries in the company UK location, the US is the highest. And then you've got NZ, I think that's New Zealand, and you've got CA, which is Canada. So that's interesting. It gives you lots of interesting information about that data set. So now we're doing another box plot on remote ratios. So if it's 0% remote, you get some money. If it's 50% remote, you get less money. And if it's 100% remote, I think you get more money as well. So that tells you the salaries of remotes, the remote ratio. So now what we're going to do is we're going to combine the train and the test. So combi equals train.append test. So we've got 378 rows by 8 columns. Check the info. You've got object columns and integers. So now what we're going to do is we're going to encode the object columns. So for call, we're going to use sklearn's ordinal encoder. For call in combi, if combi call.dtype equals object, combi call equals enc.fitTransform, combi call.values.reshape -1, 1. And that will encode your object columns. And you can see here that they've been encoded. We made a heat map. So you can see on the heat map it said employee residence is related to employee location. And I suppose if I had wanted to, I could have taken out the employee residence and the employee location. I'm not sure. I could have inserted code to remove it if it was like more than 90 or 95%. But I decided to leave the employee residence and the employee location in there. It may have improved my reading, but I just felt it was significant, so I didn't take it out. Now we're going to normalize the data, and we're going to take the all of the cells in the data frame, and we're going to convert them to a value between 0 and 1. And the reason why we do that is easier for the model to train, fit, and make predictions if the data is close together dimensionally. So now what we're going to do is we're going to define our X and our Y variables. So Y is your target, X is combi 0 row to the length of train, X test is combi length of length of trained row to the end, and then we check the shape. So you can see what the X and the X test is. And then what I do is I define the variable feature len, which is len X columns, and so that's 8. Now I use sklearn to split the data set up into training and validation sets. And now what we're going to do is we're going to define our model, and we're going to use Keras Tensorflow to define the model. And I'm new at this, so I just use, I actually looked to see if I could find better code, but I haven't been able to find better code. So we import Keras from keras.models, import sequential from keras.layers, import dense. So model equals sequential, model.add dense 500, so that means it has 500 layers. And the input dimension is the feature len, and activation is relu. Model.add dense, we've got 100 layers. Activation is relu. Model.add dense, we've got 50 layers. Activation is relu. And then model.add dense 1, and that's your output because you've got one output. And now we can check the summary. So it gives you the layer, and then it gives you the output shape and the parameter. So that's a summary of the neural network. So now what we do is we compile it, and we compile it using the loss is mean squared error, optimizer is atom, and metrics is mean squared error. And then I use 2,000 epochs. So we're going to go all the way down here. So we got our 2,000 epochs. So now we predict on the validation set. So we predicted on the validation set. We check our RMS at 61,168. And then we plot it. So you can see that there are your actual values against the predicted values. And you can see we've got an outlier. And now we make a data frame to compare the actual values against the predicted values. Now we predict on the test set, and then we submit our work to Kaggle. And that's what I submitted to Kaggle. And when I submitted to Kaggle, I got 52,392. So that's it for the code review. I've completed it using Keras Tensorflow. I'm studying Keras Tensorflow, and so I'm going to be doing as much stuff as I can with Keras Tensorflow. Hopefully it will improve my accuracy. So thank you so much for watching this video. I would like to thank my subscribers for supporting my channel. And again, thank you again, and I look forward to making more code reviews for you in the future.